To understand blockchain, it is very crucial that we have a fair idea of what hash or hashing functions are and how do they work to make the whole blockchain safe and secure. A hash function is a fixed length output for any input, irrespective of its size and length. Let's understand it in the context of Bitcoin. Transactions in the Bitcoin network work as an input for the hash function and therefore are passed through a hashing algorithm to generate a fixed length output. There are many types of hashing algorithms available like MD5, SHA-256, but we won't go into depth of these hashing algorithms. Nevertheless, it is important to note down that Bitcoin uses a secure hashing algorithm 256, commonly referred to as SHA-256. In the given example, when we pass a certain message through the hashing algorithm, it generates a hash against this input. Looking at this example, you will observe that irrespective of the size of the message you input, hashing algorithm always generates a fixed length output. Now you may be wondering, but why do we even need a hash function in the first place? If we have an input, then what is the use of creating a different output to represent that particular set of information or input? Hashing becomes very crucial when you are dealing with a huge amount of data or information. In such a scenario, the hash output can be used to track the data instead of dealing with huge amount of the input data. Now let's discuss the important properties of a cryptographic hash function used in the blockchain. A small change in the input value alters the hash value significantly. One of the unique properties of a cryptographic hash function is that even a small change in the input value brings about a drastic change in its output value. This is even referred to as the avalanche effect. In the given example, when the first input is passed through the hash function, a specific output or hash is generated. Now, when a small change is made in the input data, you can see that the new hash generated varies significantly from the earlier hash. The first input, blockchain is the future, generated a specific hash. But when a small change is made to the input, that is, an extra exclamation mark is added, blockchain is the future, exclamation mark, the new hash generated is completely different from the previous hash. This property of cryptographic hash functions makes them resistant to hacking, as no correlation can be derived about the input data by just looking at the hash alone. One of the other very crucial property of a cryptographic hash function used in the blockchain is its quick computation. The hashing function requires computers on the blockchain network to perform certain complex mathematical tasks in order to generate hash from the input data. So when we say that the hash function should be computationally efficient, it simply means that the computers should be able to finish the required mathematical task in a short time duration. A cryptographic hash function used in the blockchain must be deterministic. In simple words, a function is said to be deterministic if it generates the same hash whenever same input is passed through it. No matter how many times we pass an input, blockchain is the future through the hash function. It should always generate the same exact output or hash every single time. If different outputs are generated by a hash function for the same input, the hash function would become useless and it would be impossible to verify a specific input. The input for a cryptographic hash function can be any kind of data. This data can be a number, a word, a sentence, a passcode, a song, a book, or a complete movie. But the hash generated for any kind of input data by the hashing algorithm will be an alphanumeric code, and that too of a fixed length. It is very crucial for a cryptographic hash function to be pre-image resistant. Pre-image resistance means that the output generated by a cryptographic hash function must not reveal any information about the input data. In the given example, when an input x is passed through the hash function, the hash generated is represented as hx. Pre-image resistance simply means that even if you know hx, it must be infeasible for you to determine the corresponding input x. collision resistance is yet another important property of a cryptographic hash function. Being collision resistant simply means that it should be highly improbable to find two different inputs that generate the same output or hash. As discussed earlier, the input for a hash function can be of any type, size and length. This simply means that there are infinite possibilities for the data input that can be fed into a hash function. And the corresponding hash or output generated will have a fixed length. This means that there will be a finite number of outputs that can be generated using the hash algorithm. If inputs can be infinite and outputs are finite in number, it is quite possible that more than one input can produce the same output. So the goal of being collision resistant is to make the probability of finding any two such inputs which share the same output as negligible. If a hashing function is collision resistant, this possibility won't pose any security risk to the data. Hash functions are generally referred to as one-way functions because they are not reversible. In simple words, if you have a hash, you can't decrypt it to find the corresponding input. So in real life scenario, even if a hacker gets access to a hash output, it is completely useless as he can't decrypt it to get the input. Therefore, cryptography used in blockchain requires one-way hash functions, which makes it secure, safe and reliable. Though, hash functions can be used to track and validate the input data, but they can't be used to decrypt and reach the input data. That may seem to be a little confusing. To help you understand it in a better way, let us take an example. Suppose Mr. A holds the land titlement of a piece of land, and that information is stored with the relevant government authority in their database. Now this land record data is given a unique hash using a hash function. As the record is a centralized record, it can be tampered with and changes can be made in the records by some corrupt officials because of their personal gains. Assume that some corrupt official tampers the data and changes the land area that Mr. A owns. In this case, when the altered land record data will be passed through the hash function, the hash generated would be different from the previous one, thus indicating that the land data has been tampered with. So this is how a hash can be used to track and validate the data. On the other hand, it is not possible to decrypt this hash and find out that it represents the land record data for the land owned by Mr. A. Therefore, we can say that a hash can be used to track and validate the data, but can't be used to decrypt and find the original data.